Okay, I am asking, what would you like? Okay, I am so stupid. I was talking without unmuting my thing. Um, so what I am trying to ask is, there should be a lot of questions from you people, because this is like, you're asked to write a program. Then this is like doing design of the problem. Okay. Now, the question that you have been asked to implement is that you want your L1 and L2 caches to be there. If there is a miss in L1, you go to L2. If there is a miss in L2, you go to main memory and fetch a block. Now, the questions for you will be, since the miss rate should be less in L2, you would like to have a block size which is larger. So the questions will be, should the block size be the same for L1 and L2? One question. If L2's block size is bigger, is it okay to have a large block size in L1, which is a small cache? What are the problems if you have a large block in L1 cache? What I'm also saying is such questions should be coming from you. You should be thinking about all these questions, because after all, programming is all about, or design is all about asking such questions. How will you implement otherwise? If and I remember how much I emphasized design for you people when you did your programming. So you have to think about all these questions. In fact, I'll be thrilled the day you people raise questions, instead of just giving answers to my questions. So though I gave you now two questions, then the third question is that if there is some conflict and you have to replace one block of L2, what will you do? Because when you say I replace one block of L2, it may occupy more than one block in L1 if the block sizes are not same. Another question, should every block which is there in L2 be also present in L1, or can they be different? Can you please answer some of these questions?
Ma'am, I think it's the
Yes.
last question.
The
Like,
question is, should we have, so if you have block A in L2 cache, should it
mhm.
also be definitely present in L1, or it need not be present in L1? I mean, sorry, not that way around, this way, the other way around. If a block is present in L1, okay, block A is present in L1,
Mhm.
should it definitely be present in L2 or need not be in L2? See, there are all answers are possible. I'm sure Chakravarti sir told you multiple times in your operating systems course that there are no right answers and there are no wrong answers. That is why you have so many algorithms in operating systems. That is why you have so many algorithms in networks. You know, when you come to this stage, that is his favorite statement. I've heard him say it so many times. When you come to this stage, there is no such thing as a right answer. There are answers which are correct or good in certain situations and bad in certain situations. And you have seen that very clearly. Large block size makes sense because it reduces miss rate, but does it make sense at a L1 level? And why not? Include in L2 for some time and then overwrite it. Essentially, you're saying it's not necessary that every block which is in L1 should be present in L2. Okay, what are the possibilities for that question? Can you tell me what are all the possibilities for that question? Should a block which is in L1 be definitely present in L2? What are the various answers for that? I mean, I'm saying what are all the possible answers for that question?
Ma'am, it doesn't have to be, but since it is already in L1 cache, so the processor will the L1. But if at some point of time that gets overwritten, then it is better in L2.
Yeah. So what you're saying is, and like I said, first let us look at what are all the possible answers, right? Methodically, we can do that. So if you are doing this as a program and the design options are there in front of you, you then choose what design option makes sense to you. Okay. So the possible answers.
One can be every time.
Yes. It's always included is one answer. Yes.
Yeah.
What Subhash and Krishna said is that it will be there for some time and then it will not be there. So it can be, it's not necessary that it is there. It's not necessary that it is not there. Right? So that is a second answer. If it is in L1, it need not be in L2. That is true. But what happens, so the question is, if you feel that it should not be in L2, what are the justifications for that, right? Why should it not be in L2? I mean, like I said just now, one answer is it should definitely be in L2, and if it is in L1. Another answer people have given is it may be there, it may not be there, because initially it will be there, then it may be replaced. That's what people have said. Any other answer? That's why I'm saying give all the possible answers, then we can.
Favorable option might be not have it. If L1 has the already, then may has to have L.
Okay.
Because
So there are three possible answers, right? One answer, these are the four answers. One answer of the solution. Okay. What problem can you have with each of the solutions? So how do you analyze that? Supposing, you write to a block in L1, right? You write to a block in L1, it becomes dirty. And if you are using a write back, okay, if you are using a write back cache. Now a read miss occurs, which in English is dirty block. What do you do? If the block sizes are not same, so there are a lot of possibilities there, right? So how do we look at that? Now there is a miss for let us first start with the assumption that the block size is same across all the levels of the cache. All right. And you have a miss in L1. What will you do? Why such nice silence? My question was very simple. Hello. The block size is the same across L1 and L2. We have a miss in L1. What do we do? Krishna has said We search in L2. So basically, if there is a hit in L2, what do we do?
Fetch it to L1.
We bring it to L1.
Yeah, we copy it to L1. I mean, so, can you just say write to L1? Because I'm saying that the block is dirty in L1. What do we do? Please use the term replace the block. You cannot say write to L1 and all. You're replacing a block. Be very, very clear about the technical terms. So you are replacing a dirty block. What do you have to do in that case?
We'll have to place a dirty block within L2. L2, yeah.
You basically have to write back this block from L1 to L2. And if you don't have, so we have to, if we have to have this block in L2, otherwise what will happen? Remember those three answers. You said it may or may not be there in L2, must be there in L2, should not be there in L2. For each of them, the answer will be different. Do you agree?
Yes.
So I'm saying, see, what is this? Tell me, is it not design? You have to think of all possibilities, when you're talking about design, is it not?
Yes, ma'am.
So there is an L2 cache. This block may or may not be present in L2. Okay. If it is present, you can do a write back. Otherwise, where do you have to write it back?
To the main memory.
To the main memory, right? So if you have the requirement that every block in L1 must be there in L2, what will happen when you try to replace a dirty block in L1?
It will be written
We
back
write
to
back
L2.
to L2 instead of to memory.
You write back to L2 and then you are done, right? Because you're not bothered about the main memory.
Yes, ma'am.
Okay. It's the responsibility of L2 to push it to main memory. Now, given this sort of analysis, what would you like to design to be? There are no right answers. I'm just looking at you to analyze the situation like this. Or may not be.
Yes, ma'am. For some point of time, for certain cycles, we let it stay in L2, and then it is replaced later on. And then L1, if it is there in L1, it has to communicate to memory.
Okay. So essentially what you're saying is at some point it may be replaced in L2, though it's not replaced in L1. Why would such a situation come? Tell me. I'm interested to know what scenario would lead to the situation that you have to replace in L2 but not in L1. It's an interesting question. It's not an easy answer. I'm not saying it's an easy answer, but why would such a thing happen would be an interesting question. So let me answer that question to some extent. Supposing you have this block, you have brought it from main memory into L2 and from there into L1. Okay, we are assuming that the block size is the same, please. We are still discussing only with the block size equal in both L1 and L2. So, if there are a lot of hits to that page in L1, right? they will never be accessed. Those pages will never be accessed in L2. Do you agree? I'm saying pages. I'm sorry. Those blocks will not be accessed in L1. Do you agree?
Yes.
Excuse me. I'm talking nonsense. Okay. Let me restart. There is, you brought the block from main memory into L2 and from there into L1, right? And then your program is accessing this particular block repeatedly in L1. Okay, but not the other blocks. It keeps accessing other blocks, but different blocks. Okay. Now what happens in LRU algorithm? This block A is being accessed repeatedly. So it is not least recently used. It will not be replaced in L1. Do you agree?
Yes, ma'am.
Yes,
In L2, on the other hand, it is not used at all. Do you agree?
yeah.
Because there are always hits to it in L1 and LRU that is mostly used, so I will not replace it. So you will never touch L2 block A. Okay. So what happens? It becomes the least recently used and gets replaced.
Yes, ma'am.
Okay. So this is the scenario where you bring in the block when there is a miss. But if it is repeatedly hit in L1, it's not it's not least recently used, so it'll never be replaced. But it becomes least recently used in L2 and so gets replaced. Okay. So unless you have a requirement which says, no, you cannot replace a block which is in L1, this block will be replaced in L2.
Yes, ma'am.
Okay. Any questions on that scenario? I know these are good with diagrams. I'm going to put up, videos for the next chapter in which he gives nice, picture, he does a good job of it. So hopefully that video should help you. But that's the scenario, right? Now, the reason why you would like to have every block of L1 be present in L2 is what we discussed a little while ago. If you have a miss and because of which you have to replace a dirty block in L1, then you would like your write back to happen to L2, not to a main memory. Okay. Because that will reduce the load on the cache, L1 cache. So that is one also the reason. Now, as far as block sizes are concerned, if you have, different block sizes, and that would always mean large block size in L2 and smaller block size in L1. The reason we don't want large block sizes in L1 is because the size of the cache in L1 is less. Okay. So if you say I'll bring in fewer blocks into L1 cache and the blocks have, are beyond the spatial locality, then the number of misses will become very high because of the capacity misses in L1. Okay. So you bring in large block, fewer blocks are there. The large block contains information which is beyond the spatial locality. Okay. So, which will mean that the data there is not useful. You are bringing it, however, so your miss penalty increases, your miss rate increases. That is because of the capacity of the cache. Okay. So therefore, large block sizes are a problem in the L1 cache. But on the other hand, large block sizes are good in L2 because the size of the cache is larger. Larger block sizes will lead to miss rate being reduced. However, the difficulty is if you replace a block in L2 and you insist that whatever is in L1 should also be in L2, whenever you replace a block in L2, you have to remove all the corresponding blocks in L1 also.
Yeah.
So that is going to take time. Okay. So many such concerns are there, which leads to pretty complex design questions in caches, right? It is good to have large block size to reduce miss rate, but it is easier to handle if block size is the same across all caches. Okay, the complex logic will be very less complex if you have the same size across all block size, all levels of the cache. Then you talk about multi-level inclusion. This is what we have been discussing. Should it be in L1? If it's in L1, should it always be in L2 or it need not be in L2? So the answers are, again, if you insist that if it is in L1, it should be in L2, the logic is very simple. Okay. If it is not in L2, then the logic becomes complicated. Okay, because sometimes you'll have to write back to L2, sometimes to main memory, and so on. Because supposing, let's take the situation where you have a dirty block in L1. You have a dirty block in L1 and you have basically that block is present sometimes in L2. Sometimes it is not present in L2. Now what will you have to do? Your write back, supposing you're using a write back cache, your write back will have to go and search in L2. If it is present, it will do the write back there. Otherwise, it will have to go to the main memory and write back there. Okay, so it has to do this complicated logic about how to handle the thing. Whereas if you insist it is there in L2 also always, then it's a simple logic. Write back simply writes to L2 and it's done. Okay, so it depends on how complicated you want to make it. And the more complex logic will mean obviously more power will be consumed also. So you have to look at those aspects also about these things. Okay. So, but if your L2 cache, for example, is not much larger than L1 cache, then having this inclusion will mean that you don't have additional information in L2. Too much of additional information in L2, and that may lead to more miss rate. Okay. So if the size of your L2 cache is not very high, you would rather insist on exclusion, which means that it will not be present in L2 if it is present in L1. Then what will you do? If there is a miss in L1, then you swap blocks between L1 and L2. Okay, so you bring in the required block from L2 into L1 and push the block from L1 into L2. So you swap the blocks in L1 and L2. So this is how you need to think about your caches, whether you need to do inclusion or exclusion, or can it be that I bring it in and later, like in the example I gave, it can be replaced because it's least recently used in L2, but it is not replaced in L1. So you have now blocks which are present in L1 that are not present in L2. Okay. All possibilities do, exist. All possibilities can be implemented. The preferred thing in terms of simplicity is have the same block sizes and have them present in L2 if they are present in L1. Makes life very simple. Okay. Any questions?
Ma'am,
Yeah.
ma'am. So in case if we are writing from L1 to main memory, would it help if we don't consider if you use something like a write buffer or something, and don't consider L2 at all. Like if we consider third scenario where both of them doesn't have any data that are any blocks that are the same.
Yeah, if you have basically mutually exclusive blocks, then yes, you basically, have a write buffer.
Mm.
So if you are going to have may or may not be sort of a thing, the logic is more complex. But if you insist that they are mutually exclusive, that the blocks are mutually exclusive, then yes, you have, typically they'll use a write buffer and then let the write buffer write to main memory at later point of time.
So the competition will be between which is faster to write to memory, is L2 or is it a write buffer kind of thing?
Yeah,
When you choose what
that's right. Yeah. Write buffer will be faster than L2 because it's just a very short, small buffer, right? It'll have like maybe at the most 16 words or something. So it's very simple and it's very fast because of that. And, it's something like almost like a register file, right?
Yeah.
And then you can just in the background move it from the write buffer into the main memory. Yeah. In terms of speed, L2 will not be as fast as a write buffer, no doubt about that.
So the drawback there might be power or
Not really. In fact, write
more.
buffers are guaranteed to be present in all processors today. In fact, the next thing which is coming up is reducing miss penalty by giving priority to read misses over writes, where we talk about how we use write buffer effectively to reduce the miss penalty.
Okay.
Since Bansi is warning us that we are running out of time, I didn't move on to this. Also because I wanted to make sure that people have time to assimilate what we discussed about the multi-level caches, right? So in summary, this is what the multi-level cache thing will be. The size of L2 cache, you would like it to be much larger than L1 cache because most of the time, the implementation is that all data which is present in L1 is also present in L2. Okay, that is the reason why you want your L2 to be quite large because if it isn't, then you don't have any extra information in L2 and so your miss rate will be quite high.